The next section will be TLS. Okay. One-way SSL, two-way SSL, one-way TLS or two-way TLS, exactly. Okay. Now, the questions may be, what is a keystore? Okay. Keystore is a secure container used to store digital certificates and private keys for secure communication in a software application. It's a general concept. It's not related to only MuleSoft, exactly. But you should be aware, like, what is a keystore? See, every time we'll tell, like, configure keystore for making your service as HTTPS, then we should know what is keystore, right? Exactly. It's like a, what to say, secure container. Container means what? Something to store, right? That's it. Maybe a folder or maybe a file, exactly. Okay. A keystore is a secure container used to store digital certificates and private keys for secure communication in a software application. In MuleSoft, a keystore is used to store the private key and corresponding public key certificates that are used to secure incoming or outgoing messages through HTTPS, TLS, or other secure protocols. It ensures that messages are encrypted and decrypted only by authorized parties and helps preventing tampering of messages during transmission. See, I am telling what is Keystore. What is a Keystore? Keystore is a secure container where you will be storing certificates and private keys. That is enough. Exactly. Okay. Why it is used? To secure your services. Exactly. Okay. Now, what is a Truststore? Truststore is a, again, secure container. I used a different word called safe box. Okay. I used a secure container there, a safe box here, that stores important certificates used for secure communication between a client and server. When a client connects to a server, it checks if the server certificate matches the ones in the Truststore. See, for example, like, I want to consume a HTTPS service. What we are trying to do? We are trying to give the public certificate to client, right? And that public certificate is stored in the Truststore, right? Yes or no? Now, client will send hello. Server will give the certificate. This certificate will be validated by the client, okay, with the help of certificate available in the Truststore, right? Handshaking process we discussed, if you remember. Okay, that's what I'm trying to refer here. It checks if the server certificate matches the ones in the Truststore. If it matches, a secure connection is established. If not, it will reject. It means that we are trying to validate the server's identity here. Exactly. Okay. A Truststore is important for secure communication and helps prevent bad actors for altering messages. Exactly. Next, what is the difference between a keystore and a Truststore? A keystore is used to store private keys and certificates that identify and authenticate the client or server, while a Truststore is used to store only trusted certificates that are used to establish trust between a client and server during secure communication. Exactly. Okay. Truststore will have the certificate which the client trusted or the server trusted. Right? Got it? Yeah. Now, what is a private key? A private key is a secret code that is used to encrypt and decrypt messages during secure communication. See, as part of the secure communication process, HTTPS process, we try to secure the messages, right, by encrypting and decrypting. Exactly. Okay, for that we need some key to do that, right? Okay, with the help of private key, we are trying to do it. Private key and public key, exactly. It is a unique and important part of a digital certificate. It is a part of a digital certificate only that is kept secret and should only be known to the owner of the certificate. Why we are calling it as private? Only the owner of the certificate will know that particular private key. It should not be shared. Public key can be shared to the consumers, but not the private key. Think of it like a password that only the owner knows and uses to unlock their private information. Okay. When a secure connection is established, the private key is used to decrypt incoming messages and encrypt outgoing messages to ensure that only authorized parties can read them. Got it? Okay, fine. Next, what is public key? It is opposite. That's it. Public key is a, again, code or key that is used for secure communication between two parties. It's called public because it can be freely shared with anyone who wants to establish a secure connection with the server. When someone wants to send you a secure message, they use your public key to encrypt the message, and only your private key can decrypt it. Think of it like a lock and key system where the public key is the lock and the private key is the key that unlocks it. This ensures that only the intended recipient can read the message, and it helps prevent unauthorized access of the message during transmission. See, try to understand and keep 2 to 3 sentences in your mind. That's more than enough. Okay, fine. We have discussed this in detail, right? I think whenever our before our project discussion exactly. Okay. See, normally we use SSL word, right? One-way SSL, two-way SSL. Okay, but actually what is the one which is currently used? TLS. Okay, that's why we're trying to discuss now, explain TLS, SSL and the differences between them. Okay, both are cryptographic protocols. What are cryptographic protocols? Which is used for encrypt and decrypt and secure the communication exactly. Okay, over the internet. Both of these protocols provide a secure and encrypted connection between a client and server. But SSL is less secure, TLS is more advanced and more secure. That's it. SSL is less secure. SSL was original protocol developed by Netscape in the mid-90s. It was widely used for secure communication on the internet. However, due to some vulnerabilities found in SSL, the protocol was replaced by TLS. Okay, TLS is an improved version of SSL and it provides enhanced security features. TLS uses a stronger encryption algorithm when compared to the SSL. Okay, and provides better authentication than SSL. It also supports newer encryption protocols which are more secure than those supported by SSL. See, again, it is a separate subject. It will take a lot of time. See, SSL. What is the essence of this total discussion? SSL is an older version of TLS, or TLS is an improved version of SSL. TLS is more secure. Okay, TLS stands for Transport Layer Security. What does SSL? Secure Sockets Layer. You know this much of information, that is more than enough, at least as a starting point exactly. Okay, the difference is TLS is more secure than SSL because it uses stronger encryption algorithms and provides better authentication. Compatibility: TLS is not compatible with SSL and vice versa. For example, a system is secured by SSL, another system is secured by TLS. Whether the communication can happen in a secured manner? No, because they don't support each other. Okay, most of the systems are on TLS only right now. Okay, TLS requires mutual authentication, which means both the client and server authenticate each other. HTTPS, that only happens, right? Client will authenticate the server, server will authenticate the client. Exactly. See, overall TLS is more secure and recommended protocol for secure communication over the internet. It is widely used by websites and applications to provide secure communication between clients and servers. Exactly. Now, what is one-way TLS and what is two-way TLS, and what is the handshake process in one-way TLS and what is the handshake process in two-way TLS? Okay, what is one-way TLS? In one-way TLS, the only client verifies the server certificate, right? Okay, at the server end there will be a key store that will hold the private and public certificate of the server, whereas at the client end there will be a trust store that will hold the public certificate of the server. See, whatever we have done, that has been put in the words here. That's it. Now, what is the handshake process in one-way SSL? First, client will initiate the request, right? And it will send it will send hello and request for the resources on the secure protocol, HTTPS protocol. Then the server will respond with its public certificate and send hello. The client will verify the server public certificate in its trust store. It received the public certificate from server, okay, and it is having the certificate, public certificate in the trust store. It will match. If it is matching, then only the actual request will be sent to the server. The handshake process will be started here. The client sends back symmetric session key generated using the server public certificate. The server will decrypt the symmetric session key using its private certificate and send back the encrypted session key to the client for establishing a secure connection. Then only the actual communication and encryption will happen. Okay, all these steps will happen before starting your HTTPS communication of the request exactly. Okay, fine. Two-way SSL, client will verify, server will verify. That's why you'll have more number of steps, right? Okay. At the server end, there will be a key store which will hold the private and public certificate of the server, and Truststore which will hold the public certificate of client. Whereas at the client end, there will be a key store which will hold the private and public certificate of the client. Whereas Truststore which will hold the public key of the server. What I'm telling here, both sides Keystore, Truststore will be available in two-way SSL. In server Keystore, server private certificate as well as public certificate will be available. In Truststore of server, client's public certificate will be available. I'm telling the same here. In the client side, Keystore is available. Keystore's private certificate and public certificate of the client will be available. And in Truststore, server's public certificate will be available in the client's Truststore. Okay. Now what happens? Always client only will initiate the request, right? Exactly. Client will send hello and request the resources. The server will send the public certificate and send hello. Client will verify the server public certificate in its Truststore. Now the client sends back session key generated using the server public certificate. The server will decrypt the symmetric session key using the server private certificate and request for the client certificate. Now the client will send its public certificate to the server and the server will verify the client public certificate in the server Truststore. The server will generate a session key and encrypt using the client public certificate and send it to the client. The client will decrypt the session key using client private certificate, and this way the key exchange between client and server will happen. It will establish secure communication between client and server. Okay, got it? Fine. Already we discussed these things in detail. Now, what are the differences between one-way and two-way SSL? Already we discussed, right? One-way SSL only client verifies the server certificate. In the two-way SSL, client verifies the server certificate, server verifies the client certificate. Okay, mutual authentication will happen. That's why we call it as mTLS also. Now, sometimes they may ask you, explain the steps to make an API HTTPS service. How to do that? You have developed one API, you wanted to make that HTTPS service. How to do that? Generate keystore using genkey command in the key tool utility. Okay, with the help of Java itself, your key tool utility will be available, right? Already we seen the steps, right? What are the steps we have seen? Almost like see, create server keystore, key tool, gen key. This is the key tool utility. We call this as key tool utility, which is available in Java JRE folder, right? If you see, I have shown you that exactly. There already inbuilt key tool utility is there. With the help of that, what we'll try to do, we use a command gen key, and then we'll try to create the key store. Okay. Then what we do, we try to export that certificate, right? Public key. We'll extract public key and export that, and then we'll import it to Truststore. These are the steps, right? I'm trying to tell the same here exactly. Generate key store using genkey command in key tool utility. Configure HTTPS protocol. Configure the key store section of TLS configuration in HTTP listener connector. Yes, sir. Means you should be very clear how to configure. You should tell that exactly. You are trying to generate the certificate. Then you are configuring HTTPS, and then you are configuring the TLS section of listener, the key store part. Right? Okay. Now explain the steps to consume HTTPS service. Configure HTTPS protocol. Configure the Truststore of TLS section in HTTPS requested. Configure the Truststore in the SRC main resources, and then you can refer that particular certificate here. Is that clear? Okay. How do you generate public and private key, private certificates? You can tell I have used key tool utility available in Java. We can use open SSL also. There is some other way. Okay. I use Yenkey export and import commands for in the key tool utility. No need to remember the commands and all. You can tell I don't remember. I'll refer it in the internet and then do it. Okay. Is that clear? Now, what is symmetric encryption? What is asymmetric encryption? Symmetric encryption is a type of cryptography that uses the same key to encrypt and decrypt. This means that both the sender and the receiver of a message must have access to the same secret. Okay, what is asymmetric encryption? Asymmetric encryption, also known as public key encryption, it is a type of cryptography again that uses a pair of keys to encrypt and decrypt. This encryption technique is more secure than symmetric encryption as it makes it possible for someone who does not have a private key to decrypt the data, even if they have a public key. Exactly. See, it means that they use two keys there. Okay, one for the encryption and the other for the decryption. What is a digital certificate? Digital certificate is a file or electronic password that proves the authenticity of a server. It is like a Aadhaar card for a person. For a system, it is like a Aadhaar card. Exactly. Are used through the cryptography and the public key infrastructure. Digital certificate authentication helps organization ensure that only trusted devices and users can connect to their networks. Exactly. For example, you have your Aadhaar card. You're going to airport. They'll ask you to show your passport and Aadhaar card. They are checking your identity, right? Only authorized people are sending. They're sending inside. Okay. They will check their systems also whether this passport is there within our system or not. If it is fake passport, automatically they can detect it and they can put you in a jail. Exactly, right? Put any of us in a jail. The same way here also for a server or for a system, a unique certificate will be provided. It's like identity in the internet world. Okay, in the public key infrastructure world. That is known as certificate. It has some components again. Maybe expiry date. Even our each and every ID will have expiry, right? License or passport or anything. The same way it has also. Say try to consume the content, compare it with the real world, and then try to consume it. It will be more easier. Okay, fine. What is a self-signed certificate? A self-signed certificate is not signed by a public trusted certificate authority. See, for Aadhaar, who is the authority issuing other UIDA? Some organization is there, right? For PAN cards, you have NSDL. The same way, here there is some authority who can issue certificates exactly. But the self-signed certificate, right? We are generating on our own. It's like an ID generated by us. Okay. For example, like I am trusting you, you are trusting me. I will generate my certificate and give it, give the public certificate to you. Both the parties, if both the parties are okay, that is fine, right? Okay. That way, a self-signed certificate will be generated by the ourselves, not the publicly trusted certificate authority. Instead, by the developer or company that is responsible for the application. As they are not signed by a publicly trusted CA, they are usually considered unsafe for public applications and websites. Okay, that's why always it is suggestible to go for a digital certificate provided by certificate authority. Exactly. But for some communications, they go for self-signed. Exactly. Okay. Is that clear? Any questions here?